So hey guys, this is Varish here and welcome to the chemistry day 4. So in today's video we would be talking about how to calculate the ionic charge of an atom. So in our previous videos we talked about what is an atom and the basic structure of an atom, then what is an element and what is the periodic table of elements, and then what are molecules and compounds, and we gave an introduction to ions basically. So we gave an introduction to ions. Now what are ions? Now ions are charged particles. So atoms have got a special name if they are charged, and they are ions. So if a positive charge is flowing through the atoms, if it's called a cation or a cation, or if negative charge is flowing through an atom, it's called an anion. So cation and anion. So, and there is another definition. If there are more number of protons than the electrons, then it would be a cation, and if there are more number of electrons than the protons, we get an anion. So ions are just charged particles, atoms with a charge, a positive charge or a negative charge. So that's what is a cation or an anion. Now, how do you calculate the ionic charge? So in this video we would be talking about how do you calculate the ionic charge. How do you check if that is an ion? How do you check if it's a cation or an anion? And it's all through a simple formula. Now the formula is protons minus electrons. So the formula is a very simple formula, protons minus electrons. Now you take the atom, you find out how many protons are there and electrons are there, and then you subtract the electrons from the protons, and then you would get the ionic charge. And based on the ionic charge, you can say whether it's an ion. If it's an ion, you can say whether it's a cation or an anion. So let's go. Now, let's deal with some problems so that we get perfect in this calculation now. Okay, so let's deal with our first question. Now, carbon has 7 neutrons and 4. Okay, so an isotope. So this is an isotope of carbon. So in all these 3 questions, there are certain number of neutrons and electrons given. But mind you, not all atoms might have the same number of neutrons and electrons. They are just, let me just write it over here. They are just different isotopes or different forms of that element. But mind you, there might be any number of neutrons or any number of electrons, but the protons would remain the same because protons define an element. So these are all isotopes. You can take your own number of neutrons and your own number of electrons and try to solve it. Okay. So mind you, you shouldn't be fixed that carbon has 7 neutrons and 4 electrons. Now, carbon might have any number of neutrons and any number of electrons, but it would compulsorily have a fixed number of protons. So it's the atomic number, so it would have fixed number of protons. So there might be any number of neutrons or electrons, and then they form different isotopes as I've written. So mind you, don't check on this. Now, an isotope of carbon has 7 neutrons and 4 electrons. Find the ionic charge. Now, we don't require neutrons in this question. So basically, we don't require neutrons in this question, but they gave it, so leave the neutrons, but we require protons, and they didn't give the number of protons. And it's easy to find the number of protons. Now we have the element carbon, and carbon has an atomic number of 6, and we know that the atomic number is equal to the number of protons in an atom. So as we know that above C there would be number 6, and it defines how many protons are there in an atom, and it's called the atomic number. So from that, as we know, the atomic number of C is 6, so we have 6 protons, and now we even got the protons. Let's follow the formula. Now 6 minus 4 would give us 2 or plus 2. So the ionic charge of carbon would be C with plus 2. So it's plus 2, so it's compulsorily an ion, and it's a cation because it's plus 2. So let me explain the sum again. Now we don't have the number of protons, so as we know, the atomic number is equal to the number of protons. So it's 6, the atomic number is 6. So we got the protons now. protons minus electrons, 6 minus 4, it would be plus 2. Now, the charge of this particular atom would be C with plus 2, and it's compulsorily an ion, and it's a cation. As it's plus 2, it's in plus. Now, next question. Potassium has 23 neutrons. Now, an isotope of potassium has 23 neutrons and 34 electrons. Find the ionic charge. So, an isotope of potassium has 23 neutrons and 34 electrons. From this, we know that we don't require the number of neutrons, so neutrons are waste. Now, we required the protons, and they didn't give us the protons, and we have the electrons. And following the same method, we know that the atomic number of potassium is 19. So, as we know, the atomic number of K or potassium in the periodic table is 19, and the atomic number is basically nothing but the number of protons in an atom, and so it has 19 protons. Now, let's follow the formula. 19 minus 21. It would give minus 2. So, potassium or K has an ionic charge of minus 2. So, as we know, there is some number coming, so it would be an ion, and it's a negative number, so it would be an anion. Let's move to our next question, the third question here. Sodium has 13 neutrons and 11 electrons. Find the ionic charge. So, an isotope of sodium. Now, I guess you're not familiar with isotope. I will make another video on isotopes. So, just remember it's another form of an element. As we know, there can be any number of neutrons and any number of electrons. So, just think it's another form of that element. So, think that there would be many forms of element, and they are called isotopes just for now. Okay, so sodium has 13 neutrons, which is not useful, and 11 electrons, but we don't know the protons, so we can follow the same method. We know that the atomic number of sodium is 11. So according to the periodic table, the atomic number is 11, so it will have 11 protons. And now we got the protons. Let's follow the formula. 11 minus 11, 0. Now, we didn't get any charge over here. So, we didn't get any charge at 0. So, it would remain as Na. And when we get this particular number, we see that it is not an ion. It's neither a cation nor an anion. So, in our first case, when we solved, we got and cation. When we solved in the second case, we got an anion, and in the third case, it's no ion, it's just a neutral atom. So let me just revise it once again for you guys. Now, ions are just charged atoms. So atoms, if they have a negative charge or a positive charge, they're said to be ions. If they have a negative charge, they're anions. If they have positive charge, they are cations. And then if they have neutral charge, they are just neutral atoms. They are not ions. So let's see, by using this formula, you can find out three things. First is, you can check whether that particular atom is an ion or not. Secondly, you can check if that particular atom is an anion or a cation. Third, you can check the exact ionic charge of that atom. So now over here in carbon, we have 6 protons and 4 electrons. 6 minus 4 would give us plus 2. Now, so it's in a positive number, so it's a cation, and it's compulsorily an ion. So C with an ionic charge of plus 2. Now next, potassium has 23 neutrons and 34 electrons. So it has 19 protons, so 19 minus 34. So here I wrote a mistake. 19 minus 34. And it would give us exactly minus 15. So the charge over here would be K minus 15. So K with an ionic charge of minus 15, so it's minus 15, and we know it's an anion. And in the third case, we have 11 protons and 11 neutrons. 11 minus 11, they would both dominate each other, and finally the atom would become neutral, so it won't be an ion. So I've listed a few neutrons and electrons. Don't think that they would always be the number of neutrons and electrons in that particular element. They are different isotopes or different forms. The number of neutrons and electrons might vary, so you need to keep that in mind. So this was I guess you understood the ionic charge, how to calculate them, Hope you liked today's video. In next videos, I would be talking about other science topics or some other topic in chemistry. Until then,